Yeah, good to go. Okay, so welcome you all. So one of the SystemReady topics of the week. So obviously we are not going to go through what SystemReady IR is. Actually, you've been hard enough. So this is a follow-up of a workshop we have been done. We did actually back in February on the System RGC. So we had a workshop. And on that workshop, so we were just discussing actually what would be the ideal reference stack for a secure and interoperable Rich IoT device. Actually, and that's something we want to say here about the findings and open the discussion here in the room, actually. So this is not something I'm going to be presenting for 25 minutes. So the idea is just to be presenting for 23, and no, so it's 5 minutes and actually open the discussion for all of you. Actually, what are your thoughts, actually, and what are the next steps in terms of adopting SystemReady into the industry? So I'm very much aware that maybe not everyone is aware of what System RGC is. System RGC is the System Architecture Advisory Committee. So that mainly is where SystemReady IR is being created. So that means that obviously we have our roadmap, our needs, and our thinking of why we should be moving forward, actually, but normally this is being presented and this is being discussed within the industries, actually. So then we are taking very seriously your feedback, your needs, your priorities, actually, and that's been reflected in what we are doing next in the coming years. So anyone can join. So if you have an NDA, a generic NDA with ARM, so you can be part of this. As I said, so what we are discussing there is the direction of travel, priorities, and specs. Actually, specs is the asterisk there because EBBR, as you know, this is a community-led standard, actually, but maybe we can have some ideas that this is driving EBBR forward. As said, so one of the discussions we had on the System RGC was, I think it was Pete Robinson was mentioning is, well, so it could be really a really good idea is to have a face-to-face discussion with all the members when we can discuss is what a good reference implementation should look like. What are the things we should be considered, actually, and that's what we did. Actually, we meet for 2 days. We had people from ARM SystemReady, for PSA, PASEC, obviously Linaro, actually Red Hat, Canonical, LBFS, ST, Eurotech, 56 Cloud, and Foundries, and we were just kind of discussing this. That's roughly what we discuss and how we arrange the sessions and a bit of the outcomes. And that will lead to the beds of a further discussion for today. So if you look at the software stack diagram, that's a very simplified software stack diagram, actually, but that's quite representative. And what we wanted to do is just split the discussions into 3 different areas of interest. First of all is what are the governing principles driving the design choices? Actually, so then when you have to do a design, what you have to consider in order just to build that up in terms of boot capabilities, in terms of maintenance capabilities, in terms of security capabilities, right? Then afterwards, we also want to just to tackle what are the standards supporting those principles. Actually, we know that, okay, so those principles are well represented from a UFI perspective, from a SRS, all the combinations of BBR, EBBR, BBSRs, device trees, so on and so forth. And then finally is whether there are existing technologies supporting those design choices and supporting those standards. Actually, obviously, we are talking about U-boots, EDKs, TFAs, OPTs, and all that stuff. What was the outcome? Actually, the outcome was probably when we started there, so we said, okay, so we're going to be finding a lot of gaps. The truth is that there were not so many gaps. Obviously, there are gaps, actually, so I think that we have seen a few presentations during that week just stating the clear gaps we have there. But most of them, they are kind of like corner cases. We already have covered quite a lot of ground in terms of what's been done already. So actually, so there are not so many many gaps, actually, and that's a bit of a list of the gaps we are seeing, which are very minor, I would say. Actually, I would say that what we have today is very, very stable. Probably as Peter was claiming and claiming, actually, so the biggest gap today is documentation. Actually, what are those guiding principles we were mentioning at the beginning? Actually, so this is something that we, probably a few of us, we know, we share them, but there is no clear documentation to say that if you want to do secure boot, that's how you can do it, actually, and those are your options. So this is something that, if you are new into this, you can find yourself lost very easily. So then good documentation is still something it is missing. In terms of boot level, so worth mentioning, and I said this is a corner case, actually, kind of a chain of trust issues when mixing U-boot and TFA. If you're using TFA as an example, everything is very much covered, actually, but when you are mixing U-boot, well, I mean, for BL2, actually, SPL, actually, with TFA, that you have issues there. HTTP, HTTPS, boot issues, more related to installation than the booting itself, actually, but that's a building block for FIDO, that's coming for the future, not also something which is very concerning today. Maintenance, we've been discussing about this and BIOS during this week, actually, this is something which is, well, LBFS and AB support, as an example. We know that TFA is supporting AB and so on and so forth, but from a system-ready perspective, it's not mandated there, right?
Yeah, thanks. And from the AB updates, we also came to the conclusion that we might need to go forward to the EFI spec and request some changes to support that thing. So there's more gaps that we're trying to fill in and make a standard out of that.
Yeah. So in terms of firmware update, obviously all the building blocks are there. So we've been working with ESRT, firmware capsule updates, authenticated capsules, GUID. So everything is there, actually, but we have reached where potentially the missing bits are AB support. So then this is something that has to be worked. And then finally, security. So the funny conversation there is kind of a bit miscommunication or misconception about system-ready and the security interface extension. So security is not achieved through system-ready. System-ready is not guaranteeing security at all. So security is achieved through PSA. So PSA is the one that is just looking after your implementations and making sure that your system is somehow secure at different levels. System-ready is looking at the interoperability of your security artifact or structures or services. Actually, if you are using TPM as an example, that you are using TCG2, actually, and that TPM is probably being advertised to your parsec and so on and so forth, actually. But we are only checking that the interfaces are there, but how it's been implemented, that's a quality thing. Actually, this is not within the scope of system-ready. So as I said, so no major concerns or no major things that we will just discover. So then I would say that the reasonable question then is, well, so if there are not so many gaps, actually, what is so hard for vendors to make system-ready as a default option on the BSPs? Because that's not happening. Actually, this is something we have heard quite a lot this week, is I've been exploring 15 different platforms, actually, and none of the platforms is being shipped or is being deployed with the system-ready enabled hardware, or is not system-ready capable. Actually, why is this? Actually, if they are certified, what's missing? What's missing there on the journey? Actually, and that's what I wanted to ask openly here. Actually, yes, I said that should be a kind of an open discussion and get your opinion. Is that what would be potentially the path for less resistance on just working with vendors, just in order to make that happen?
I think part of the missing piece is customer demand, but that's starting to grow.
Mm-hmm. When you say customer demand, is from what level on the supply chain? Actually, is from obviously when you say the SIPs, OEMs, ODMs, kind of fleet managers,
like the end user customers, so the enterprises that are using the devices.
Mm-hmm. Okay. Is something you are experiencing actually from your Red Hat perspective? Is that you are?
From Red Hat perspective, we're mandating system-ready for all our platforms just for ease of support. But it then becomes complex because the vendor or the customer will go and speak to the hardware vendor, say I want system-ready, and then they will start to look at it. But the customer has timelines for projects and things like that. Mm-hmm. So we've got a few system-ready platforms that we actively support, and we've actively worked with the vendors on. Mm-hmm. But obviously, and there's a lot of like AMD, Xilinx, various others that are actively working on it. Qualcomm, we heard earlier today, is moving to it as a default. So I think we're sort of on that cusp where when other hardware vendors start to see, the Qualcomms of this world going that route, they'll just sit there and go, oh, what are we missing out on?
Comments? Vincent?
Maybe a quick word to add to what you were saying about the default option. So I think here the point is not to replace the existing boot path in those products, but rather to make sure the UFI boot path is also present in addition to the legacy boot path, for example, not replacing the legacy boot path, right?
Yeah, well, so it's somehow that the UFI path is not a hidden configuration. Actually, it is being supported. It is being documented. It's within the how-to guides on the BSPs. Is that if you want that option, that's how. Normally, it's not there.
I mean, just to add on the demand and ask, we're on the more customer side, so where we're going to the ODMs, we're taking the devices and putting them at customer use cases. And most come to us like, how can we de-risk this data by, we don't want to just go with, this particular ODM, we'd like to stick with maybe IMX or different processor or TI platform, but we need to know that our software works on other devices, in case the supply chain challenge or whatever. And then they come over and say, well, there's this program, it looks like the, let's say, Intel Inside logo, and if you carry the SystemReady logo, you can ask that, and then that creates the business case. And we've had a project where one of the vendors competing for that project, in the time they had one edge device that already had a SystemReady certification, and then I had another one from a different vendor, and then the third one, which didn't know about it at all. In the space of this 4 or 5 month proof of concept, they went and got SystemReady. They realized, okay, this puts a good argument on the table that the business can relate to, de-risks the buying in or getting locked into a specific platform, and we can maybe potentially change. They will go with one vendor at a time. So I found that was a concrete use case where we could bring the value of SystemReady further up the business chain.
Thank you.
Yeah, I think on that is I think what we need to push is at least for the SoC manufacturers and with the Qualcomm hat, of course, that's the direction they're doing is by default the BSP is shipping a SystemReady compatible firmware. If of course source code is going to be available and so on, if someone wants to change it and reduce the scope and optimize for for the product, that's fine, right? So, but still the default to be SystemReady. Of course, one of the issues that at least we see with XP-based hardware is not the BSP itself, is the some vendors and everyone that is creating products and creating and forking basically, for example, U-boot and other pieces, and then they're doing their own thing, and then it creates kind of a mess, because at the end of the day, you could think IMX8 is certified, right? But the EVK is certified, and now you get from some random, some manufacturer, and you have the same expectations, but then you get in there and they're based on an old firmware, they change it, this and that. So I think it's where most of the pain is at the moment.
Okay, so then you think that the starting point for those ODMs is not the BSPs coming from the EVK, so they change it completely, or?
Depend on the quality of the software engineers in those companies, right? So sometimes they do changes or they fork old versions of it. But I think if the message is you can do whatever you want that is specific to your platform, but try to at least by default ship whatever that the BSP vendor is actually shipping. So a SystemReady compatible one. Then I think that's. But it's a messaging, right, that needs to send across.
And an education thing.
Yes.
We've heard.
That's exactly. So it goes back to documentation, right? It goes back to documentation and educating people how to do it properly.
Yeah. Well, actually, that also comes with the supply chain. When at the end of the day, when we are saying that, obviously, the supply chain starts from the silicon vendor, OEMs, and all going up. The assumption actually is that if the SIPs are not deploying and they are not providing BSPs with that good documentation or kind of the default option for SystemReady, no way that the next level up on the supply chain they are going to be using it. So then at some point the whole thing is lost.
if the silicon vendors, BSPs, default to System Ready as part of their examples, I think you'll see a lot more adoption further down the chain.
Yeah. Do you comment that?
Yeah, so one way in which the firmwares are built and produced is Yocto. A lot of Yocto layers for the different vendors and their BSP stacks, they don't, first of all, produce system-ready firmware by default. Basically, they're missing a machine configuration. Second thing is, I hope ACS testing or whatever testing for the compatibility with system-ready, I think they should be available, a generic test which you can run on multiple BSPs and see whether they're compliant or not. I think maybe that's the case already. Maybe I'm just not educated enough. But then what is then missing maybe on top of that is some kind of a CI-based verification or a Yocto community tag that they can put into their meta layer. Hey, by the way, this default machine config is compatible with system ready. Take it as your, let's say, initial starting point if you care about system ready. If you don't, you can optimize all the bits and pieces away that you don't need.
Yeah, I fully agree, actually. So this is something which is not here, actually, but yeah. The certification, yes, is snapshot in time, but somehow that's a continuous effort. Actually, that should be part of the continuous integration, actually, and that ACS is not something that should be a tool used by the certification engineers. So the ACS should be a tool used by the developers engineers just to make sure that whatever is being done according to these standards, actually, and then you can just check your BSPs and so on and so forth. And that can be done in-house. Actually, there's actually no need. Well, actually, I shouldn't be saying that, actually. There's no need there for being certified, actually, but you can be capable. You could be system-ready capable, actually, and without any need of sending that to a certification house, actually, because you have the tools. And you should have that, actually, and that there's no reason why you couldn't have all your BSPs, all your multiple configurations tested against that,
Yeah, so one of the, let's say, Yocto is in general machine and use case specific build. But once you have, let's say, success in your marketplace, you have multiple variants, possibly multiple SOCs, possible for multiple vendors, and that's when it comes really cumbersome to do SOC specific builds, variant specific builds. You want to have a generic build. The solution in the Yocto community into this direction is the generic ARM64 image build, which should be one of the, let's say, test beds for any system-ready firmware. Does it boot that?
Yeah, I believe that's the generic ARM64, which landed in the last version, is going to be introduced as an option, but it's only been out, like the latest version of Yocto has only been out a few weeks, I think, so that'll take a while to adopt that.
Yeah, and when we need basically some kind of entity which runs tests against this image, does your BSP firmware hardware combination boot this image? Mm-hmm. It needs to be someone who runs this in the community. Yocto upstream is quite busy.
Yeah.
I think it goes back a little to documentation, right, and how we teach people how to do it. Like everything is available, like the ACS images and so on and so forth. Like it's pretty easy to execute and run. There's the script for parsing, like Vincent does a lot of work maintaining, like all of those. So it's actually pretty easy now to consume. So, and then I think it's more kind of an education, right? All right, you got it at some point, but you want to keep, like the certification in place, then just, maybe, I don't know if Lenaro is doing that kind of CI internally, or like at least that is publicly available, then we can show people, like this is how we're doing. So if you want to mimic the same behavior.
Yeah. Do you think it's only education? Actually, I fully agree. Education is a key part of it. But if you look at the spread or the share of Linux distributions in the market, 95% is Yocto, 5% is the others, right? So then, obviously, vendors are focusing on where the market is. Actually, it's focusing on that 95% of the market, which is Yocto. So then enabling the 5 remaining % today is costly. So then probably the question is that for those that you are working with Yocto, makes any difference yes to be system ready compatible or not, or compliant or not? Actually, is more costly to be system ready compliant, or is that truly a design choice?
I think it comes down to documentation and defaults. If now we have the default ARM64, I suspect a lot of new projects will start there just because they know they can run that across a number of devices. Yeah. And, improving documentation.
But you think that it is not more complicated? Once you are educated, it doesn't require more cycles? It shouldn't be.
Yeah, on Yocto, of course, like it's a bit special in a way that you can start with something that, can be easily certified, like a generic image or whatever, but then people always change and optimize in whatever means is necessary, right? So then, for example, they wouldn't have to keep like two basically CI loops, right? One is that's kind of product specific or whatever the demands they have, and the other is like the generic path, right? So in order to not break, right?
Yeah.
It's costly in the end if they want to maintain it, but at least like for zone vendors and OEMs, like
They can do that.
They should do it. Yeah.
Yeah, okay. Yeah, obviously, understand from legacy perspective, actually, if you have kind of a 20 years of legacy working with, well, Yocto doesn't exist for that, but if you have kind of a deep legacy there, so making the changes, actually, that's costly. So then you have to have a very positive cost-benefit balance, otherwise you are not going to do it, right, I guess.
And on the Yocto and CI topic, so the One Lab project announced by Linaro yesterday, part of that is actually to run the Yocto generic image on systems to verify that they can actually boot that.
Yeah. Actually, but I guess this is not solving what he was mentioning, actually. But if you already have a Yocto image with custom layers for your specific device, changing into this.
No, but
is costly. Actually, is something that should become for free, or
if you have a stable image on Yocto that people can augment on top and not change the boot process, stop supporting EFI, then it shouldn't be hard. That's the whole point of SystemReady.
Yeah.
And on the One Lab thing, it's also automating the ACS testing, right? So it's both of if you look at the pillars, it's ACS, it's the installers, and the capsule. So we're trying to cover all that.
I have some, just in case we were stalling, actually. So I have gathered some of the comments during the week, actually. So there's, I'm just bugging you off with questions and all that stuff. And that's something I have included. Probably worth validating with you guys, actually, whether you agree or you disagree with this. Actually, something that the first statement, SystemReady is seen as an admin process rather than a design requirement principle. It's like you have your firmware. Actually, you have a candidate. Actually, you pass the tool's ACS. So that's the first time you run ACS, and surprise, you are not compliant. And at that time, you start to panic, actually, and you start to fixing everything. Instead of defining SystemReady or EBBR or BSAs or whatever as your design input, actually, you are designing for that. Actually, so this is something that in some occasions we are experiencing, and some feedback we have received that SystemReady or the specs related to SystemReady are not part of the design cycle. It's been seen more formal process at the end of the journey, just to say, okay, do it, and if it works, fine, if it not.
The interesting thing about the 95% of the market, like, I'm guessing that's for one particular hardware vendor. Because, like, if you look at the edge IoT market as a whole, 100% of the Intel market is UEFI based.
I'm looking, obviously, SystemReady ARM based.
Yeah.
And even if it is, right, let's assume it's 95% of the market. The point is not that. The point is that you could decouple yourself as an ODM from the vendor. You could decouple yourself from the OS you're trying to run, right? So if something goes wrong and Yocto doesn't run anymore on your board, you can run Red Hat, Fedora, you can run some other distro, right? So that's the whole point.
The whole point, and that's what we are trying to sell that somehow, is that today is a clear dominance, custom builds actually, but we believe that's not the scenario for the future. So the future is going to change. There's going to be more 50-50 probably.
Well, and like, a lot of the customers I speak to are concerned about things like, supply chain issues that we've seen over the last couple of years. They want to be able to change out components, boards, SOMs, whatever, so that they can continue to ship a product and be in business. And so things like that, and also things like, the European Cyber Resilience Act and things like that, enabling, easy update and long-term support for platforms, I think will very much, and like discussions I've been having over the last 6 months has certainly indicated that, things like the CRA are starting to have big concerns for vendors, and, they need to, they need to be able to move around, and so, there's numerous sort of reasons for this now.
Yeah, I agree. So that was kind of a backup slide just in case, actually, but where we see that those are the different markets, kind of a cloud native, edge IoT, and embedded IoT, where that's where SystemReady IoT sits. That's today where the green is the one dominates in the market because it's the custom builds. But if you look at the trend, so that's going to change massively because the reasons you said, actually. So if you have a common security line for all your devices within your organization, this is something is going to change.
This is the boring part, right? We need to get it once and get it right and forget it exists. So we can boot to the OS and do stuff that actually matters. There's no point, there's no competitive advantage.
Yeah. Something else.
Make SBSA. You just need to make SBSA hardware.
Yeah, but I'm not a silicon vendor.
No, actually, but that's something that I have received as well. Actually, that's the bit at the end. In some occasions, there's a very clear decoupling between hardware system engineers and software, actually. And for a system engineer or a hardware engineer, how EBBR translates into hardware is difficult, actually. And they only find that at the end of the thing. That's complicated.
So it's not only BBR specific, right? The EFI spec has a role to play in that as well, of what hardware you need. There are some implications, and we need to write them down at some point with the guidance.
I'm very conscious about time. Something I would like to validate with you guys, actually, is that one of the comments is where we are seeing, or we have seen, or something you have comment, is normally the system-ready-based framework, which is being used for the certification, is not the main trunk of development. This is something which is a fork. So you create a fork from the main trunk, actually, that is only supporting one configuration or only supporting one device, and you start working with that just to make it system-ready compliant. So that takes a huge amount of time, a huge amount of effort. So that means that you are diverging from the main trunk quite significantly, actually, it's 1 year of diversions. And then at the end of the day, actually, so that's the one you end up certifying. Actually, then you have two options. Actually, what do you do at that time? So you backport to the main trunk, or you stay as it is? What we are saying is that half. Some of them, they say that, you know what, I'm not backporting that to the main trunk. Then that version is not maintained, is not supported, is not public, actually, and that's what some of you have mentioned. Actually, it is impossible to find the images I've been certified for because that's kind of an academic or kind of an experiment, a trial, dying on a fork.
If the silicon vendors supported it well out of the box with their BSPs, you shouldn't need to do that. And if the documentation was better, you shouldn't need to do that. Like, it should be, relatively straightforward and a handful of K-config options in the build process.
Yeah, and that's the question is why they are doing that on a fork. Well, I know why, actually, but yeah, obviously is if you are doing that on a fork, somehow you should be backporting back to the main trunk. At some point from there, you should be evolving from that system ready, actually. And the question probably is that if it's the ones not doing this is because they don't see fully the value of backporting that into the main trunk, actually, and say, why I'm going to do that if the just work promise is not yet being delivered? So that means that work still needs to be done. So then if work needs to be done on my system-ready firmware base, also work needs to be done on my main trunk. So then why to do the backporting? So this is something that...
Yeah. So on firmwares, if you are talking about long term, we should encourage people to use LTS of firmwares. And also in the different firmware projects where they don't support LTS releases, let's encourage people to do LTS so that backporting is easy. So one of the reasons for not backporting is the master has moved very far away and backporting a lot of effort. In LTS, it's easy to just put a couple of patches for defects.
The backporting is the easy part on that. It's harder to educate the community to add fixes tags that you can find and backport without having to go through the entire mailing list, right? That's the hardest part. Picking up the patches and merging them is the easy one.
Well, in some occasions, backporting implies when you have that fork is for a single configuration or a single device. Backporting, that maybe you have to support all the different configurations, all the different products, and actually it's not for one product. So it's kind of 200 different, and that's hard. So then you have to have a very good justification why you are doing this.
Well, you've got, if you're working on upstream U-boot, there is no LTS, and that moves pretty quickly. If you're working on a, some silicon vendors BSP, like most of the main silicon vendors rebase maybe once a year to a new version. So if you're doing it in, a branch on a BSP, it's probably not moving that quickly. But when they bring out the release the following year, they will have to rebase, and there's probably some more work there. So it depends on their development workflow.
Yeah.
One thing about words. I will not use form backported, because usually this developer trunk is older than the main trunk. Like SoC vendor takes whatever U-boot is today, and they work on make it work.
Yeah, it's merged.
Right.
It's not backported. It's not backported.
Half year later, they still have March version of U-boot running, and September version just came, right? So they are merging the support to the main trunk, not backporting.
My bad. You're right.
Yeah, so this relates to the upstream first versus development on an LTS branch thingy,
Yeah.
which, I mean, for the engineers doing the work, they need to do it multiple times. The pain of updating the patches to a new LTS kernel version, new Yocto version for the whole distro stack or the whole firmware stack is horrible compared to having the small bits and pieces of them updating to master sooner. But still, it's hard to tell as a customer, as someone in the community, for the vendors, please don't develop on the LTS branch. Please try to submit your patches earlier. Please try to develop on the master main branches. I know it's easier, but it will be more expensive later on.
Yeah. Thank you. Yeah. Yeah, of course. Questions? No more? I think we are on time. Yeah. Guys, thanks a lot. It was useful.